Hey folks, this is Anatoly. I'm CEO co-founder of Solana Labs, and today I'll be presenting an update about Solana and how much growth we've had over the last year. So what is Solana? Solana is a high-performance layer 1 blockchain. We benchmarked this thing to be over 65,000 TPS, and it's designed to run at 400 millisecond block times. And its launch was last March 2020. We actually launched right in the middle of Black Thursday, right when all the markets crashed. So it was kind of an exciting time to go out to market and try to build a new ecosystem. The exciting thing about Solana is that it is a blockchain that's designed to horizontally scale with Moore's law. And what this means to us is that as hardware improves in a single server performance improves, meaning that a single server has more cores, more IO lanes, more network capacity, more network queues, more SSDs, more IO ops to those SSDs, then the chain becomes faster. And what that really means is that the chain becomes cheaper to users. So even though our fees right now are probably some of the lowest, if not the lowest in the industry, what we really care about is how do we get these fees even 1,000 times lower? So where do we find all those improvements in performance and get much cheaper, build a much cheaper network for users? And there isn't any one single thing that makes Solana fast. There's a bunch of little optimizations all across the network. And we put a lot of work into really optimizing each piece that a blockchain does when it handles transactions, and all of them together is what actually makes Solana great. So one of those pieces is proof of history, and it may be the most famous one in Solana, and I often think of it as really as almost like a sand clock or a water clock. So it is a way to introduce a source of time to the network that is outside of consensus. So this is a way to look at the level of time passing. And the way that you do that is there's a verifiable delay function that continuously runs on every node. And the progress that this VDF makes, the amount of progress that this VDF makes is what moves the logical clock in the network forward. So it starts functioning as a classic Lamport clock. And because it is bound in real time by how much time it has to, that any node has to take, it starts approximating real-time passing in the network. And once you have a source of time, it becomes easier to coordinate nodes around the world. And we use this as a, to our advantage to make the network faster and simpler. The other optimization that most folks have heard of is this thing called Turbine. And this is a way to propagate blocks in real time around the world. This is actually maybe the more, the one that has the most impact, because this is how validators are streaming data in real time. So blocks are not composed and then transmitted one by one and shared one by one. A leader that is the current block producer is ingesting transactions that are proposed, verifying them, and encoding them into the block in real time as that block is being streamed, and in real time is generating erasure coding. So it's much closer to how video is transmitted, how audio is transmitted around the world. And the way that this data is streamed is it's chunked and propagated at random around the entire globe simultaneously. So validators are expected to retransmit and recombine the data into blocks and do this all collaboratively. So the impact of all these improvements is that we've seen the network grow in very significant ways in objectively measurable metrics for decentralization. So we try to measure decentralization as the cost to destroy the network in terms of destroying every copy of the state. And those copies are hosted by validators, and we see the number of validators has been doubling every 3 months. So when we launched back in March, we only had about 40 validators when we started. But because this network does something special, the kind of growth that we've seen in the validator community has been really astounding. So we're really excited about it. Right now, it's at over 1,000 voting validators, and there's actually a lot of non-voting validators, RPC nodes, and those I think add up to about 700. And they add to decentralization as well, because every node that holds a copy of the state is another copy that can provide the reliability that we need in case, in the worst case scenarios. So, you know, whatever you may think, you know, what are the possibilities that the network could fail or crash? You only need one valid copy to continue. The other side of decentralization that we focus on is this idea of the Nakamoto coefficient. And it's really important to us because this is what provides real-time censorship resistance. It's this idea that when I send a message, how do we guarantee that it actually arrives to all the validators, to every valid copy? And the only way to really guarantee that is to maximize the minimum set of nodes that could possibly stop it. So right now on our mainnet, that number is 19, and I think this might be the highest for proof of stake networks. So in real time, the minimum set of nodes that would have to collude to block any block from propagating is at least 19. What's great is in our testnet, we are validating this number across similar set of nodes, similar hardware, also globally distributed, run by volunteers, but the Nakamoto coefficient there is over 500. So this isn't so much a technology bottleneck. This is really a bottleneck in terms of how do we distribute stake? How do we decentralize the stake itself? How do we spread this weight of stake weight across the entire network and maximize this? And there's a lot of progress being made around our ecosystem to support this. So one of the ways that, you know, how did Solana grow? And I honestly think this was because of this demo. So in those early days when we launched March last year, no one's heard of Solana before, and we built this little game, if you want to call it a game, where you smash the keyboard and every keystroke sends a transaction, and you can see it being sent and then confirmed. So by the time that thing lights green, it means that 2/3 of the network has confirmed this transaction in such a way that we know that at least some of them would have to be provably slashable for this block to revert. So this gives the finality guarantees for a lot of applications that run on Solana, but it also demonstrates to the users that blockchains can be fast. They can be actually in real time. And those Web2 applications that people want to build that have, you know, the look and feel of a Web2 application, but Web3 features are now possible. When we launched too, there was, you know, we built our own Rust compiler to target Berkeley packet filter. And there was practically no easy way for developers to build applications. It was almost like building on an embedded system. So you have to kind of dig in deep and discover how does Solana work? How does the memory model work? And throughout this process over the last year, folks in the community have put together their own frameworks that make development on Solana, you know, as easy as Ruby on Rails. So one of those is Anchor, and it's one of the it was trending on GitHub for a couple weeks as the most popular Rust project. And using Anchor, you know, going from an idea to a smart contract on Solana, you can cut that time down from, you know, a week to a few hours. So this is pretty awesome frameworks. If you're starting to build on Solana, I highly recommend that you use Anchor. You know, we have this thesis that blockchain is fungible, that users may not care which network their transactions execute on, and what they care about is what they're touching, what they're executing, what applications they're using. And to facilitate that, to actually make block space fungible, you need bridges. You need bridges from Ethereum to Solana. You need a bridge from Solana to Ethereum and across all the other networks out there. So this team out of Certus One built this bridge called Wormhole. And this is a multi-chain bidirectional bridge that can transfer not only tokens, but also NFTs and every other, in fact, is a generic message passing framework. So you could write handlers to call between smart contracts between two networks. So the way I think of Solana, you know, my background is, you know, spent a career at Qualcomm. I'm an operating systems engineer. I worked on the earliest operating systems that ran, you know, mobile platforms like Brew. And I think of Solana as an OS first. So Neon is a EVM implementation of the EVM bytecode interpreter that runs as a Solana program. So it is actually, you know, its own virtual machine running inside Solana, but this runs inside the same state as the rest of the Solana programs. It is no different than any other, you know, smart contract or program on Solana, but it is able to handle Solidity compiled smart contracts, and it's also able to provide the same interface that Ethereum Geth users are expecting from their RPC layer, you know, through use of proxies and shims. And to me, this is really, really cool because it demonstrates that the execution layer and kind of the data availability layer and the real-time block propagation pieces that we built can be leveraged by all of the smart contracts out there, not only just the Solana ones. So we're really excited about Neon, and they should be launching, I think, within a month or two. So our ecosystem exploded. There's nearly 500 projects that have launched so far, and a ton came from our hackathons, and they kind of go across every possible, you know, vertical that you see in blockchain. We're really excited about the gaming and NFTs. There's been over 1 million NFTs minted on Solana. And to me, NFTs are really important because this is the first time that I'm seeing casual users, you know, sometimes kids, both be the creators. So actually artists that are, you know, high school students are able to build their art project as an NFT. And then on the consumer side, they're very, you know, non-financial based applications that are purely for fun. And this is what I think might lead, you know, and spearhead adoption for blockchains around the world. So one of the applications that actually makes this possible is this amazing wallet called Phantom. So I would recommend folks that have been mostly using MetaMask or any other blockchain wallet to just go check out Phantom. It is, I think, the best UI in wallets out there, and they've been growing like crazy. About 100,000 new users added every week, and of course they support NFTs and every other kind of application you might want to use on Solana.
Hi, could you hear me?
Please check it out. So our community is been growing as well in a pretty significant way, and by that I mean is our hackathons, which are very developer oriented, have seen a ton of registrations grow from one hackathon to the next. But more importantly, the number of projects and teams that have been forming has been yeah, at least doubling between every hackathon. So the last hackathon that we've seen, the Solana season 1, had over 350 project submissions. And out of those, I think around 50 teams or so actually formed as companies. So these are now, you know, funded seed stage companies that are building on Solana with their own funding, their own runway, their own business models, and that, you know, willingness to eat glass and launch a company is probably the most important part that that makes an ecosystem. So how many engineers can you convert into, you know, build their own dream, and how many of those can you empower? So right now we are just about finishing the Solana Ignition Hackathon, and we had over 568 total submissions. So this is more projects than the entire ecosystem before the hackathon. It's kind of crazy. Basically doubled the number of applications or the number of devs that are building. So we're really, really excited about this and see what how many of these teams actually form and stay on and build real companies out of this. There's a lot of other kind of bigger applications coming into the space, and these are not your typical blockchain applications. So if you heard of Chingari, which is an Indian TikTok challenger, they've raised their own funding and they're launching a social token on Solana with a lot of integrations to come. And they already have 60 million users. So what we're seeing now is this kind of rush for Web2 companies to convert themselves into Web3. And you know, in my mind, this is just the beginning, because the number of users that you see in Web2 is, you know, 3 billion people on the internet, but the number of actual users that sign transactions and actually use blockchain between all the networks right now is maybe 10 million tops. So we're going to see a massive growth of Web2 users converting into this Web3 users, and really excited to see how that turns out. And these applications are not strictly what we expect out of blockchains before. So these are Web2 applications, they're social networks, they're music networks like Audius, and this is really bringing blockchain to consumers in a totally new way. So if you're thinking about building on Solana, or you just want to participate in the community, check out our Twitter link or our website. And we have pretty good docs that can always be better. Yeah, just jump in and start building. Thank you.